Welcome to Random Maths and welcome to video 2 in the Finite series playlist. Today we'll be discussing a special type of finite series known as an arithmetic series. So let's look at the general definition of an arithmetic series below. So an arithmetic series, I spelled that wrong, an arithmetic series is a series from r is equal to 1 to n of AR such that AR is equal to AR minus 1 plus D for R greater than 1, where D is a natural number, so a positive integer, commonly referred to as the common difference. And the reason for that is if we take any two adjacent terms, or basically terms next to each other in the sequence, or terms next to each other in the summation, then we get, and we take them away, we're always going to get D. So that's the reasoning behind the common difference. Basically that is why it's a common difference. Okay, we've already seen an example of an arithmetic series as well, and I'm going to go on to that in a moment. When A1 is just equal to A1, so it's just a starting term, and then each term in the series, or in the sequence, because the series is just the sum of all terms in a given sequence. A given sequence is defined by taking the first term and then adding the common difference. That's our definition of what this sequence is. So yeah, so we take the first term and we add terms on, so we can actually solve it AR for A and get it in terms of A1. So what I mean is, let me just show you below. So we've got AR is equal to AR minus 1 plus D, right? So then let's have a look at the next term. So AR minus 1, sorry. Before that, let me just say, so R and then R minus 1, what we do is we take 1 away. So let me get rid of that line, give me more space. We just take 1 away. But that rule follows for every other term, so let's have a look. So AR minus 1 is equal to AR minus 2 plus D. Because for R greater than 1, this holds. So this, take away 1, so R minus 1, take away 1 gives R minus 2, and if you don't believe me, I'll just show you. Minus 1 gives minus 2, so quite, I mean it's obvious. Let's go to R minus 2 now is equal to AR minus 3 plus the common difference again, D, and again the same kind of thing applies. We're going to take 1 from that to get the D. Scroll down, then we got A2, or A3, sorry, is equal to A2 plus D. Again, we're just taking 1 off. And then we've got A2 is equal to A1 plus D. Last time I'm going to do it because I know it's getting on your nerves now. We get it. Come on, don't keep going on, Phil. So A2 is equal to A1 plus D. So and we take 1 off on each term. So why is that useful? Well, obviously we've obviously got A1 is just equal to A1. So why is that useful? Well, it's useful because we can now get AR in terms of A1. So we can iterate all the way back to the first term and get it, and I'll show you here. So what I mean is AR minus 1, AR is equal to AR minus 1 plus D, but AR minus 1 is also equal to this. So that's equal to AR minus 2 plus D plus D, and then that's going to be equal to AR minus 2 plus 2D. And also notice as well that whatever we're taking off is going to be the multiplier here. So whatever we take off is the multiplier. Okay, so then AR minus 2 plus 2D. Well, AR minus 2 is given by that formula. So we've got AR minus 3 plus D plus 2D, which is equal to AR minus 3 plus 3D. And again, we've got that this term here is the multiplier here. And let's just go down, so we go dot 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 dot. So when we get down to, for example, when we get down to substituting in what A3 is, what's A3? Well, no, sorry, let's go down to A2. We can skip right to the end. We need to do A. We need to do 2 more steps. It's redundant. But let me just point out that 2 is equal to R minus 2. Because that was obviously just R minus 2, which is going to be plus 2. And obviously 1 is just equal to R minus 1. The reason I'm saying that is because when we're substituting in A2, so we've got something in terms of A2, what we're going to be doing is we're going to be doing AR minus R minus 2, which is going to be A2, but we're putting it in this term format for now for a reason. So that's going to be R minus 1, sorry, because we're substituting in A2, plus D, right, and we already know, so in this case we've got 1 less than N here, got 1 less there, so we've got 3 there, we've got 2 there, we've got 2 there, we've got 1 here. That kind of makes sense. So in this case, what we're going to have is we're going to have 1 less here, so we're going to have 1 less there. So 3 minus 1 is 2. R minus 1 is plus R minus 2D. And then that is obviously going to be equal to A1 plus, so R minus 2D plus D, so R minus 2D plus D is equal to RD, right, minus 2D plus 1D, so minus D is equal to D times by R minus 1, so plus R minus 1D. So essentially to summarise what we've got is AR is equal to AR minus 1 plus D, which is one way of saying it, or AR is equal to A1 plus R minus 1 times by D. I prefer this method, or this equation, because it gives it in terms of things we already know. So we already know what A1 is, so we can just easily work out what AR is. We don't need to iterate, because with this formula here we're going to have to iterate R minus 1 times to keep solving back before we can say what AR is. But in this equation we don't need to iterate at all, because we know what A1 is, we know what R is, take 1 away, we know what the common difference is, we can do it all with one sum. The point of all this though, sorry, I've kind of gone off track trying to explain that, but the point of all this is that's how we can add up each term. So each term of the sum is going to be given like this. So remember last time when we looked at, so we're looking at the generalised sum. We've got R is equal to 1 to N of AR, which is equal to the sum from R is equal to 1 to N of A1 plus R minus 1D. So that's how we can also define the sum. So this is the form of an arithmetic series which we're going to use in order to get a nice solution to the arithmetic series. And it's a little trick we're going to do. So remember as well last time we said that nth partial sums can also be written as Sn as well. So that's what how we're going to write this as Sn. What we can say is this. So we've got Sn is equal to, well, let's put r is equal to 1. So we've got a1 plus 1 minus 1 times d, which is a1 plus 0d. So we've got a1 plus a1 plus 2 minus 1 plus d plus a1 plus 2d plus, and again when we get to the nth term, plus a1 plus n minus 1 d. So for the adding up the n terms, we've got this. So that's great and that's cool, but how does that help us get a nice form for Sn? We know Sn's this, but we want a nice version of Sn, because in order to find Sn at the minute we need to add all these terms up. So all these terms here, we've got to add every one of these terms up in order to get Sn. But there's a nice little trick. If we write the sum backwards underneath, we can put a1 there, right? And then so we're going to literally write the sum backwards. So we've got a1, and we're going to go to, so here's going to be a1 plus n minus 1d. And the one before was going to have a1 plus n minus 2d plus a1 plus n minus 3d as well. The reason I'm saying this, because now if we add both, if we get 2Sn, we add both of these lines together. So we add this line plus this line, we get 2Sn. But what else do we get? Well, if we add both of these together, what do we get? Well, we get a1 plus a1, okay, 2a1 plus n minus 1d. So this is equal to 2a plus n minus 1d, right? Okay, well what is this equal to here? Okay, well a1 plus a1 is equal to 2a1. 2d plus n minus 3d, well that just becomes 2a1 plus n minus 1d. But if we're gonna subtract 1 from here and then add 1 to here, it's always going to be the same. So this here is also going to be 2a1 plus n minus 1d, and this right here is also going to be 2a1 plus n minus 1d. And how many terms do we have? Are we summing? Well, we're summing n terms. I've already said we're summing n terms. So it's going to, each term, so we're going to sum n of these, and all of these added together give us 2a plus n minus 1d. So essentially what we're doing is we're doing n terms times by 2a1 plus n minus 1d, which is equal to n over 2 times by 2a1 plus n minus 1d. Okay, so that's a generalised formula of it, but we can even go a bit further. Well, what's a1? Well, a1 is the first term, so n over 2 times by a1, which is the first term. And we're going to say, well, if a1 is the first term, what's the last term? So L, which is going to be the last term, is going to be, well, we already know what the last term is. The generalised formula of the last term is just this, in blue. So L is equal to a1 plus n minus 1d. So essentially what we're saying is all we need to do is we need to take the first term plus the last term, then look at how many terms are in the whole sum, divide it by 2, multiply it together, and that's a generalised formula for Sn. So we've got Sn is equal to n over 2 times by a1 plus L. So what I have now is a new general definition of an arithmetic series taken from the first one. So an arithmetic series is a series from r is equal to 1 to n of, and I can put it like above, a1 plus r minus 1 times by d, which is equal to n over 2 times by a1 plus l, where a1 is a positive integer, so where a1 and d are positive natural numbers to be defined, and L, I guess L as well will be, and L equals, so A is just 2A is A1 plus n minus 1d, yep, so A1 plus n minus 1d. So that's an arithmetic series is a series of this form, which is equal to this, where these terms are positive integers and this term is given by taking the a1 and d and doing the following. And we can also say d is equal to common difference again. And there you go. That's a different way of defining an arithmetic series. It's a more interesting way of defining it, really, because we've got the solution to any arithmetic series now as well. So let's have a look at our example again. Go back to our example. We've got the sum from r is equal to 1 to n of r is equal to what? Well, let's have a look. So we've got a, we need to get it in, we need to get this in terms of that, right? Well, the common difference, and then common difference, everything. So we need the first term. The first term is 1. So because a1 is always the first term of the sequence, right? So this is first term of sequence. Yeah. So this is going to be from r is equal to 1 to n of 1, because it's the first term of the sequence, plus r minus 1 times by d, correct? And obviously 1 plus r minus 1 times by d, what does that equal? Well, d is where d is 1. Common difference is just 1. D is equal to 1. And we can find the common difference again by just taking any term and taking it away from each other. So d is equal to 1. So it's just equal to that times 1, which is the common difference. But then, well, what is that? Well, that is just going to be, give us back that, so times by 1. So we've got 1 plus r minus 1, which is equal to r. So we know now that this is going to be n over 2 times by a1, which is 1, plus l, which is the last term. Well, the last term is going to be n. L is the last term of the sum, so n. So it equals n over 2 times by n plus 1. Okay, let's give a a harder one. So obviously, when we're looking at the sum from r is equal to 1 of 10 in the example we had, well, we got 10 over 2 times by 10 plus 1, which equals 5, times by 11, which is equal to 55. And we know that's right, so there you go. Then we've also got a harder sum, so let's have a look at 3r plus 4. Now there's two ways of doing it. We can even use this rather than using the other way, because if you looked at the last video, I defined something called the, so have we got the notes in the last video? So just checking how long I've been running for, 20 minutes here, so we're going to try and end this video soon. So if you looked at the last video, we found that the addition and the scalar multiplication rule can be used in situations like this, so we can even say a more easier way to work this out. That's going to be equal to 3 times by r plus 4. We've used a scalar multiplication rule with it. We use the addition rule initially, and then we use a scalar multiplication rule. I've kind of combined the steps. So you can go to 2 steps in order to get to this, but we'll do it. So we do the addition rule first. Look at the last video for that. This is 3r plus the sum from r is equal to 1 to 10 of 4. But that's then equal to the sum from r is equal to 1, 3 times 10 of r plus the sum from r is equal to 1 to 10. So 4 plus 4 plus 4 plus 4 plus 4 10 times, just 4 times 10, correct? So, because that's just 4 plus 4 plus 4 10 times, so that's just going to be 40. That's going to be equal to 40. This is going to be equal to 3 times by 55. So what does that equal? 50, 150, 165 plus 40, which is 205. But let's look at the generalized. So you can even just by knowing this, you can pretty much solve all arithmetic series using the addition and scalar multiplication rule. But let's look at it, do it properly as in we've been taught. We know the common difference is going to be 4, going to be 3, sorry, and that's because if we look at, we got AR minus 1, it's a common difference, which is equal to 3r plus 4 minus 3r minus 1 plus 4. 4 cancels, so it equals 3r minus 3r minus, so minus 3 plus 3, which is equal to 3. So the common difference is going to be 3. So what we have is we've got the first term, which is going to be 3 times by 1, which is 3, plus 4, which is 7. So again, remember, we can rewrite it like above. So we can rewrite the equation like this. So let's have a quick look again. We can rewrite it like this. First term, 7, plus r minus 1 times by the common difference, which is 3. So I'm going to put it on the other side because it makes more sense to put it on the other side. And obviously that should equal to 3r plus 4, does it? Well, let's have a look. 7 plus 3r minus 3, yeah, 3r plus 4. Okay, so this is going to be n over 2, 10 over 2, times by the first term plus the last term. Once it's in this form, basically once it's in this form, we know that this equation holds, because we proved it. We've got it into that form, so now we can just use this. We know what it's equal to. So the first term plus the last term, so we've got 7. The last term is going to be 7, it's going to be 3 times 10 plus 4. 3 times 10 plus 4, so plus 34. So what we've got now is 10 over 2, which is equal to 5, times by 7, 34 plus 7, which is 41. 41 times by 5, well, what does that equal? 410 is times 10, 410 divided by 2 is just 205. I hope that kind of makes sense. I know it wasn't the best of videos, I know it may have confused you in places. Let me know in the comments, I'll try and improve it in future videos. I may re-upload this video and do it differently if there's a lot of complaints. But I hope you've now understand what an arithmetic series is and how to apply it in the future. Thank you for watching, and see you in the next video.